this last section of chapter 6.5, we're going to learn how to use proportionality theorems. So our first theorem right here says triangle proportionality theorem. So notice that the figure to the right is indeed a triangle. So the proportionality theorem says if a line parallel to one side of a triangle, okay, so this is one side of a triangle, and here's a line parallel to it. So if that line intersects the other two sides, so it intersects here and here, then it divides the two sides proportionately. So what are the two sides? The two sides are this side. Whoops, sorry. Let me highlight that. Hang on 1 second. I'm going to highlight it, but then it's going to go away. So you may want to highlight it yourself. So here is this side. Whoops. Can't really do a straight line. Okay, this side of the triangle and then this side of the triangle is being cut by that line segment UV, which is parallel to the base of the triangle QS. Okay, that's what's happening. So it says if TU and QS are parallel, and we know that because of the red arrows, then, so look at what they're saying, RT over TQ. Okay, this piece right here over this piece right here, that proportion or that ratio is going to be equal to RU over US. So what I want you to notice is that we're not comparing the big triangle with the little triangle. We are no longer doing that. What we're doing now is we're focusing on these two parallel lines, and the proportionality we're saying exists is between the big piece over this little piece on the top of that triangle and the big piece over the little piece on the bottom. So you could reduce these so that you can see that they're both the same, or you can do the cross products and see they're both the same. Either way, you can prove that that is indeed the case if you have numbers there. Otherwise, this is the theory behind it. Okay, so I'm going to turn off that marker so you're going to not see that blue lines anymore. Okay, so let's continue on to the next page. Well, I guess further down this page. So here's another theorem. So what was the first one called? Just going back up for a second. The first one was called the triangle proportionality theorem. This is the parallel line theorem. So notice that you don't have any triangles, but you do have 1, 2, 3 parallel lines. Okay? Those are the parallel lines, and the lines are S and T, and the transversals are line L and M. And that harkens back to our days of parallel lines and transversals. Okay, so this theorem's going to say if 3, so you need 3, parallel lines intersect two transversals, then they divide the transversals proportionately. Okay, so set up the proportions of the transversals. So UW over WY, that's the top transversal, is going to equal VX over XZ, which are the parts of the bottom transversal. Okay, so you got that? So what we're talking about is when these lines intersect these transversals, and the transversals are line L and line M. When they get intersected by lines that are parallel, and how many do you need? You need 3 of them. Then this piece here, UW over WY, has exactly the same ratio as does VX over XZ. Okay, that's the parallel line theorem. Okay, let's continue on. Here's a third theorem. This is the angle bisector theorem. Okay, so you have an angle that's been bisected. How do I know it's been bisected? Well, first off, what does bisected mean? It means that an angle is cut into 2 equal parts. So this angle right here the top red, equals the bottom red. Okay, so that's been bisected. So if I knew what the measure of ACB was, then I would know what ACD and DCB was, because I would just divide it in half. Okay, so that's what bisected means. So if a ray, so here's your ray, which is CD, arrowhead one direction, bisects an angle, here's the angle, angle C, then it divides the opposite side. Okay, where's the opposite side from this angle? Right over here, into segments whose lengths are proportional to the lengths of the other two sides. Okay, so AD over DB equals CA over CB. Okay, so this ray comes along, it bisects the angle, it then creates AD over DB, and that's the same as CA over CB. Okay, so you have three different theorems. So let's go on and see if we can continue with the notes. So here's an example. Okay, so what do I have here? I see I have parallel lines here. I only have two of them. So this was the first theorem. So what this is saying, if this line segment inside the triangle is parallel to this, what do I know happens? So I believe if I make this an X over here, so I'm just going to draw this in. I want you to draw it in as well. So right here is going to be an X. So X over 9 equals 4 over 6. Those are the proportions that happen. So wherever this parallel line is cutting, they become proportional. X over 9 equals 4 over 6. Okay, so when I do this, I can then check the cross products. So 4 times 9 has to equal 6 times X. 4 times 9 is 36. 36 divided by 6 is 6. So just, you may want to fill in these other pieces. So when you do your cross products, what do I get? I get 6x equals, and it's really kind of rough to draw with this, equals 4 times 9, which is 36. Okay, that's happy. There we go. Okay, divide. Your job is to isolate the x. Divide by 6. Divide by 6. This is equivalent to 1, so x equals 36 over 6, which gives you x equals 6. Okay? So that's what I want you to write down. So all the things that you've just seen, make sure you have that written down. Because as I move down the page, the blue ink is going to go away. So you need an x over here. You need this equal sign connecting these two fractions, and then here are your cross products right here. Then divide both sides by 6 to isolate your x. Okay, so get that down, or go back to it if you need to. All right, let me slide down a little bit more. Okay, so look what I have here. Ooh, I have the 3 parallel lines. So when I have those 3 parallel lines, what happens? These proportions happen. So what I know is that this over this will equal this over this. Okay, now the problem is, look right here, this was blank, but this whole thing was 6. So if this whole thing is 6, and this is 4, then this must be 2. You have to supply that number 2 information. Otherwise, you're not going to be able to resolve this issue. Once you put the 2 there, you can then say that 2 over 4 equals 4 over x plus 2. Okay, we're back to cross products. When you do cross products, go very easy. 2 times x is 2x, plus 2 times 2 is 4, and 4 times 4 is 16. So I'm going to subtract 4 from both sides. That gives me 12 equals 2x. Divide both sides by by 2, and I get x equals 6. So I can check this now. So go back with what I had. 4 is to 2, just like 4 is to x plus 2. But now put a 6 where you had the x, and verify that 2 over 4 equals 4 over 8. Cross products tell me that 16 this way equals 16 that way. I have verified it. All right, so that was the three parallel lines. Set up these proportions. This is the angle bisector. So what happens when you have an angle bisector? So when you have an angle bisector, as it comes across, you set up 16 over something. Oh, here, let's do 16 over something. So let's see. Do I want that? I may have to look at this for a second, because I don't believe I want that. So hang on 1 second. Let me think about this. Okay, so I've done some fancy work over here that I'm going to need to explain to you. So you want to have 16 over whatever this is. I don't know what that is. What I do know is that to get this piece, I'm going to take this whole piece and subtract away 16. So look what I have in the bottom. If you say 2x plus 8 minus 16, don't you get 2x minus 8? So do that for yourself. Just make sure that makes sense. So this is 2x minus 8 in the bottom, and that represents this piece right here that's unknown right this minute. That has to equal, look what's on the same side as the 16, that's the 20, over 15. I then made this smaller. I made this 4 over 3 by dividing the top and the bottom by 5. Then, really carefully, I can make this simpler by dividing the 16 by 2 and getting 8, the 2 by 2 and getting 1, and the 8 by 2 and getting 4. That makes my job so much easier. Now do your cross products. 8 times 3 is 24, and then this is x minus 4 times 4, which is 4x minus 16. Add 16 to both sides. 24 and 16, 6 and 4 are 10, and the 0 carry the 1. 2 and 1 is 3, and the 1 that you carried is 4. That has to equal 4x, divides both sides by 4, and you get x equals 10. So then I said, okay, if that is the case, let's see if I can check it out. Well, I know that 20 over 15 has to equal, I want to figure out what this number is so I can check the proportion. So if this is 2 times x plus 8, and x was 10, this is 28. 28 minus 16 gives me 12. So this other proportion is 16 over 12. And I will leave it to you to do these cross products and make sure they're the same, knowing that you can also reduce these fractions and then do the cross products. So that's for you to test so that you have a better understanding of that. Okay, so here's another one. It's another angle bisector problem. That was the third theorem we learned. So look what I know. I know that if I have an angle bisector, which I have, the result is this ratio, 7 to 13, equals this ratio, QR to RS. Now, I don't have a value for QR, but I do know that this is 15 on the outside. So 15 minus x has to be QR. So here is my setup. 7 over 13 equals 15 minus x, which is the QR, over x, which is the RS. Okay, you cannot cancel these x's. Doing that, you'd have to divide 15 by x, which doesn't help you at all. That would give you 15 over x minus 1, and that would be a nightmare. Do not cancel those x's. Instead, cross multiply. 7x equals, okay, 15 times 13 is 195. Do that off to the side. Minus 13 times x is 13x. Okay, so now add 13 to both sides, and I get 20x equals 195. Divide by 20. Okay, here's how I divide by 20. 20 goes into 19. It doesn't. It's close, and therefore I know that 20 goes into 195 9 times. 9 times 20 is 180. Subtract. That gives me 15, and bring down the 0. That's going to be a decimal now. And 20 times what? Times 7 gives you 140. Subtract and bring down. I have 100 now. And then this is a 5 because 20 goes into 100 5 times. So I should put a little dot, and I'm going to instruct you to do the same thing right here, and here, and here is a decimal. Okay? So I'm getting 9.75. That's how many times 20 goes into 195. So my answer is that this x over here should have been 9.75. Now you could also say it was 9 and what? And 5 over 20 15 over 20 remaining. Okay, you could do that. 9 and 15 twentieths. That's a fine answer. That's the same answer as 9.75. So just think about that. Okay, so let's keep going down. I first need to get rid of this marker. Okay, so that's gone. Okay, so let's slide down. Give me 1 second. So now here is your homework. So here's parallel lines within a triangle. That's the first theorem. Look that up as we go through it. Here's number 2 is 3 parallel lines. That's the second theorem. And then the problem to the right of it is an angle bisector problem. That's the third theorem. We've done all the practice for those, so go ahead and apply what we've done. Number 3 is also the angle bisector theorem, and I changed, make sure you have these little marks that are triangles instead of whatever they were, and this should be a similar. Okay, so I have everything set up for you to be able to do this work. Okay, so that's it. So you've got a couple of little problems. See if you can get your problems done, and then I want you to submit these notes and the problems for your homework before the start of next class. Okay? So we're done.